You are listening to The Vocal Technologist. Spoken tech for your ears.
Imagine hiring the most brilliant security auditor on the planet. I mean, someone who can spot a microscopic hairline fracture in a decade-old vault door from a mile away.
Right, a total prodigy.
Exactly. But now imagine that same undeniable genius happily handing over the keys to the vault just because someone walked up and handed them a sticky note that said, give me the keys.
It is a totally bizarre contradiction.
Yeah.
But, that is exactly the reality of artificial intelligence in cybersecurity right now.
Yeah.
We are building our entire digital infrastructure around these entities that are simultaneously brilliant and, entirely gullible.
And that is exactly what we are unpacking today for you. I mean, keeping up with the relentless pace of cybersecurity news right now feels like drinking from a fire hose, especially if you're prepping for a big meeting or just trying to stay informed without getting completely overwhelmed.
Absolutely. There's just so much noise.
Yeah. Right. So our mission for this deep dive is to cut through that noise. We're looking at a wild snapshot of the InfoSec landscape from the first week of June 2026. And we're not just listing off breaches, we really want to extract those aha moments to uncover the underlying patterns of how the digital world is breaking and, well, how it's being defended.
Yeah, because to understand the threat landscape, we have to look past the surface-level panic. We're going to connect the dots between, like, a hacked video game cheat site, the security of enterprise AI, and the foundations of open source code.
It's a massive scope. So let's start with that genius security guard paradox. We're seeing AI operate as this incredibly lethal bug hunter right now.
Oh, absolutely. So, for example, OpenAI's Codex model recently discovered this hidden HTTP2 bomb.
An HTTP2 bomb?
Yeah, it's a remote denial of service attack affecting these massive foundational web servers like Teamchix, Apache, and Microsoft ISIS. And the really wild part is that it wasn't even a brand new flaw. No, I mean, the underlying techniques are a decade old. It basically chains together what's called an index reference bomb with a 0-byte flow control stall.
Okay, wait, let's break down the mechanics of that. How does a stall actually take down a massive server?
Well, think of it like ordering a massive, intricate banquet from a restaurant kitchen. The client sends a highly compressed request that is the index reference bomb.
Okay, I follow.
And that unpacks into a huge order. The server's memory works frantically to prepare like all 32 gigabytes of this data. But then the client sends the flow control stall.
Which does what?
They essentially tell the kitchen, wait, my plate is full, hold the food at the window. So the server is forced to pin that massive amount of memory in place indefinitely.
Oh, wow. So it just clogs everything up.
Exactly. It chokes on its own queued data and crashes. And what's crazy is that 5 independent software implementations read the exact same protocol guidance and shipped that exact same bug.
Because the original documentation framed the risk poorly.
Right. And an AI was the one that spotted that systemic cross-platform logic flaw. Because AI operates at a scale and speed that human auditors just can't match.
Right. It can map the whole topography.
Yeah, and spot microscopic anomalies. We are seeing this pattern everywhere. Like an AI security tool recently dug up a 2-year-old use after free bug in Redis that lets attackers take over servers.
Use after free, that's a memory corruption issue, right?
Yes.
Is it like returning the key to a hotel room but secretly making a copy of it?
That is a perfect way to visualize it, yeah.
Yeah.
The application basically tells the operating system, hey, I'm done with this block of memory, the room is empty.
Right.
But the attacker has kept a pointer, a copy of the key to that exact memory address. So when the system allocates that empty room to a new, highly privileged process, the attacker can just walk right in and drop a malicious payload right on the bed.
That's terrifying. And the AI mapped out the exact sequence required to pull that off.
It did. Researchers are even taking local open-weight models like Gemma and combining them with specific testing harnesses.
Like the Iron Curtain harnesses.
Exactly. They used a local AI to reproduce Anthropic's Mythos, finding a 17-year-old remote code execution vulnerability in FreeBSD. It's hunting through decades of legacy code and just finding needles in the haystack.
Wow.
Anthropic is even expanding its project Glasswing to point these AI hunters at critical infrastructure. Power, water, healthcare systems.
Which sounds like a massive leap forward for defense. But we have to flip the coin here because this is where that sticky note analogy comes back.
Right, the gullibility.
Yeah, while these large language models are brilliant pattern matchers, they lack fundamental common sense. I mean, they have zero boundary recognition. They are completely vulnerable to prompt injection and context manipulation.
The Meta AI Instagram hijack is such a perfect example of this.
Exactly. Attackers didn't break Meta's encryption or anything. They spoofed their location using a VPN, opened a chat with Meta's AI support bot, and just used prompt injection.
They tricked it.
They basically told the AI, hey, link my new email address to this victim's account. And the AI, just trying to be a helpful assistant, simply bypassed standard security protocols and sent a password reset link to the attacker. It literally handed over the keys.
Because the AI doesn't understand the semantic difference between a user request and a system command. It just treats all input as instructions to follow. We saw the exact same flaw with the ChatGPT vulnerability.
Whoa, right, where ChatGPT blindly trusts browser content?
Yeah. Security researchers found that if it reads malicious markdown code from a web page it's summarizing, it doesn't just read the code as text, it renders it as its own instructions.
Oh, man.
So it can generate convincing phishing links or fake QR codes right inside the trusted ChatGPT interface. You think you're interacting with a safe sandboxed bot, but it's essentially rendering an attacker's weapon directly onto your screen.
But the threat surface is expanding way beyond just active interactions, right? Like into passive background processing. Let's talk about the Gemini voice assistant hijack.
Oh, the fake context alignment attack. Yes.
This one is wild. Attackers sent silent WhatsApp or Slack notifications to a user's phone containing hidden instructions. And Gemini processed those incoming notifications, read the instructions, and executed them without ever speaking them aloud.
Right. It could control Google Home devices or launch calls entirely silently.
Wait, I need to stop you there. How does a voice assistant execute a command silently? I mean, isn't the microphone the primary trigger? It has to hear a wake word first, right?
Well, that's the intuitive assumption,
Ugh.
but it's not how modern OS integrations work anymore. To be helpful, Gemini hooks into the operating system's notification stream to build context, so that when you do speak, it already knows what you are doing.
Okay.
So the attacker sends a WhatsApp message with a payload hidden in the text. The operating system parses the notification. Gemini reads it to build background context, but because it lacks that boundary recognition we talked about, it blindly parses the text instruction embedded in the notification and just executes it,
Completely bypassing the microphone?
bypassing the microphone and the wake word entirely.
So the AI is just quietly reading your background messages and obeying the hacker who sent them. That is terrifying.
Yeah.
And then you have the University of Toronto demonstrating an AI worm. Like, it's an open weight model that, once it infects a machine, literally hijacks the computer's resources to power its own reasoning engine. It searches for disclosed vulnerabilities, adapts its code, and spreads autonomously.
Exactly. So if we know AI is this incredibly powerful but easily tricked entity, what happens when the very code used to build these models is secretly written by the attackers themselves?
Oh, man.
That naturally brings us down to the foundational layer, the software supply chain. Attackers aren't even bothering to break down the front door of the company anymore. They are poisoning the water supply before the house is even built.
Right, the erosion of developer trust. Let's look back at the infamous XCU DILS hack from a couple of years ago. The core issue there wasn't a coding mistake. It was a maintainer trust hijack.
See?
Yes. An entity named Jia Tan spent 2 full years contributing legitimate code, earning the trust of the open source community just to become a co-maintainer. And once they had the keys, they slipped a back door into the release files.
And standard security scanners didn't catch it at all because scanners look for known bad code,
Okay.
right? Like a list of published vulnerability signatures. They do not have the capacity to ask, hey, is this newly written code structurally safe?
Right.
The backdoor was obfuscated within legitimate-looking test files.
I really have to push back on standard security advice here because we are constantly told as users, use multi-factor authentication, use a password manager, be careful what you click.
Sure.
But if the open source code running the servers is poisoned by a rogue maintainer who spent 2 years building social trust, aren't we basically putting deadbolts on our digital windows while the foundation of the house is made of quicksand?
Honestly, your pushback is entirely valid. User-level security advice is necessary, obviously, but it is wholly insufficient against supply chain attacks. When the foundation is compromised, the locks on the windows just don't matter. And this is happening constantly now.
Like with the Red Hat NPM backdoor.
Right, dubbed miasma. Attackers compromised a Red Hat employee's GitHub token.
And a token is essentially a digital VIP pass, right? It lets automated tools talk to each other without needing a password every time.
Exactly. And they used that stolen token to push 32 backdoored packages into the ecosystem. These packages carried a hidden payload designed to harvest developer credentials. I mean, AWS, Google Cloud, Azure, Docker credentials, SSH keys.
Wow.
They infected the internal development tooling just to steal the infrastructure keys.
And the scale of these poison tools is just wild. There was a tool called Codex UI, which was a remote interface for OpenAI Codex, getting like 27,000 downloads a week.
Yeah.
It was secretly stealing OpenAI refresh tokens and account IDs and sending them to an attacker-controlled server disguised as Sentry telemetry.
And the mechanism for hiding that was incredibly simple. The malicious payload wasn't even in the public GitHub repository. It was only compiled into the NPM package the developers actually downloaded.
So they audit the public source code online
Assume it's safe.
and download the distributed binary, completely unaware it contains an injected token stealer.
Precisely. And these attacks are becoming so sophisticated in how they chain small permissions together.
Yeah.
The Apocalypse attack chain is a perfect narrative of this.
Oh, right. Attackers started inside Zapier's Python sandbox. They found a flaw that let them execute system commands.
But a sandbox is supposed to isolate that execution.
Right, but the memory space wasn't properly isolated, so the attackers just started scraping the memory heap. It's like leaving your bank login on a scratch pad on the desk after using a public library computer.
That's a great way to put it.
The attacker just reads the residual memory. They found orphaned Amazon Web Services tokens, used those tokens to bypass Docker monitoring by making raw API calls to pull container images, and ultimately they were able to leak high-privilege NPM published tokens.
Wow.
They chained together half a dozen small, obscure flaws just to gain the ability to publish malicious code as a trusted entity.
It's incredible. Even the development environments themselves are vulnerable. A researcher recently found a one-click token stealing vulnerability via a bug in github.dev, which is the browser-based version of VS Code.
One click.
Literally one click on malicious link and your OAuth token, which grants access to all your private code repositories, is silently stolen. What all of this points to is a systemic failure in how we handle trust. We just assume that if software comes from a known repository, it is safe.
And attackers are exploiting that exact assumption to compromise maintainers and distribution channels. But this massive web of compromised tools and poisoned code doesn't just stay in the developer realm. It directly impacts everyone listening to this.
Because when infrastructure keys are stolen, it leads to one disastrous outcome. Corporate databases get breached, and our personal data gets completely exposed. Which brings us to the human impact of the data hoarding epidemic.
The downstream consequence of every compromised system we just discussed, corporate data mismanagement is turning what should be minor, contained breaches into historic mega breaches.
Right.
The Columbia University breach is infuriating. I mean, they exposed 1.8 million social security numbers. But here is the kicker. That included people who never even attended the school.
Unbelievable.
They were hoarding decades-old recruitment and testing data in a forgotten legacy database from 2025. I mean, Columbia's data hoarding is like keeping 20 years of your neighbor's tax returns in a soggy cardboard box on your front porch, just in case you ever need to verify their address from 2005. Why do these organizations refuse to throw anything away?
Well, it's driven by cheap storage and institutional inertia. It costs almost nothing to keep a cloud database running. There's often a legal or operational fear within organizations that deleting data might cause a problem down the line.
But the real liability is keeping it.
Exactly. And Columbia wasn't alone. DentaQuest, a dental benefits provider, suffered a ransomware leak exposing 2.6 million records, full names, government IDs, health insurance info. The World Food Program had a breach exposing the data of 600,000 households in Gaza through a self-registration application.
And it isn't always a sophisticated hack either. Sometimes it is just a mind-boggling misconfiguration. Like Microsoft had a forgotten debug flag in 6 of their Android apps, including massive ones like Word and Copilot.
This is a really great example of a mechanical failure. A debug flag is essentially an exported Android component meant for internal testing, but it was left public.
Which means?
That meant any other app on your phone could send an intent, like a basic internal message, to that component. The Microsoft app would blindly process the request and hand back the user's authentication token.
You're kidding.
About 15 lines of code could silently steal your Microsoft account access tokens, exposing your emails, files, and calendars. That single line of leftover code put billions of app downloads at risk.
And this data collection extends everywhere. There was a duplicate vote.gov site, named Trump RX, designed by the National Design Studio.
And looking at this objectively, I have to say, regardless of anyone's political affiliation, left or right, the technical reality is highly concerning. The investigation found that the site was collecting user analytics via a tool called PostHog.
Despite its own privacy policy explicitly claiming it did not collect such data.
Exactly. When the technical execution of code completely contradicts the written privacy policy on government-affiliated sites, user trust is fundamentally broken. Undocumented data tracking is a universal security concern.
I couldn't agree more. It's about the technical reality that our data is being tracked, hoarded, and leaked everywhere. So how do we actually fight back against this reality?
Well, the deep dive material includes this fascinating breakdown by an investigative tech reporter, Yael Grauer, of her actual real-world privacy stack. She calls it a vibes-first approach.
I loved that. I found that psychological heuristic incredibly insightful. Her first line of defense isn't a piece of software, it's her reaction to urgency.
Right.
She treats any sense of urgency or pressure, like a text saying an account is locked or an email demanding immediate action, as an immediate red flag. She pauses and verifies it through a separate, trusted channel.
Yes. It's an operational lifestyle, not just a product you buy. Like, she uses a P.O. box for clients. She actively scrubs her address from data brokers. And technically, her setup is intense but practical.
She favors physical security, right?
She does. She uses 3 YubiKeys instead of passkeys because she wants physical, hardware-level control over the authentication. She uses 2 different password managers, 1Password and Bitwarden.
To compartmentalize her risk, so if one is breached, she doesn't lose everything.
Precisely. She also utilizes Mulvad VPN, employs Apple's lockdown mode for severe threat reduction, and notably, she avoids biometrics.
Because in her specific threat model, a fingerprint or a face scan is a static identifier. If a password leaks, you just change it. If the biometric data securing your device leaks, you can't change your fingerprints.
Exactly. Her approach demonstrates that true privacy is about building layers of friction against data harvesting.
It's about taking back control, freezing your credit, using Signal with disappearing messages. She acknowledges it adds friction to her life, but it reduces the unnecessary exposure that leads to your social security number ending up in some leaked, forgotten database.
So, if we synthesize this entire journey, it paints a very clear picture of the current architecture of cybersecurity. We are increasingly relying on hyper-intelligent AI systems that can audit decades of code in seconds.
Yeah.
Yet these same systems can be entirely compromised by a silent text message because they lack contextual boundaries. And these systems are built on an open-source software foundation that is actively being targeted by patient cybercriminals who spend years building trust just to poison the code.
Right, and the result of all this structural fragility is that our personal data is sitting in forgotten, misconfigured databases just waiting to be leaked or silently tracked.
Exactly.
It really is a lot to take in. But before we wrap up, there is one final mind-bending concept from the research that we haven't touched on yet, and I really want to leave you with this to chew on.
Okay, let's hear it.
We talked about Yael Grauer's perfect privacy stack, but there's a vulnerability detailed recently called Frost.
Ah, yes.
It stands for fingerprinting remotely using OPFS-based SSD timing.
Right. It is a timing side-channel attack, and it is a brilliant exploitation of physical hardware.
I want to make sure I'm explaining this right because it's wild. Even if you use the perfect privacy stack, you do everything right. You use a VPN, you block trackers, a malicious web page can figure out what other tabs you have open on your computer, like your bank account.
Correct.
And the way it does it is by writing a massive chunk file to your browser's origin private file system, which essentially clogs up your solid-state drive's controller.
Yes. The attacker's script measures exactly how many milliseconds it takes to write that file.
Yeah.
Because different websites, like a complex banking portal versus a simple blog load, different asset patterns.
Right.
So they require different read-write operations from your SSD. By correlating the slight latency delays in your physical hard drive, the attacker can guess what else your computer is processing. It basically creates a unique physical signature of the bank's website.
That is just crazy. So here is the takeaway question I want to leave you with. If attackers can literally listen to the physical timing of your hard drive to steal your secrets, how do we build digital walls when the physical foundation itself is talking?
That is the big question. It entirely forces us to reevaluate what a secure boundary actually is when the hardware itself is leaking intent.
Exactly. Keep asking those questions, keep looking past the headlines, and stay curious. You might be navigating a complex landscape, but once you understand the architecture, you don't have to be overwhelmed by it. Catch you on the next deep dive.
Spoken Tech for your ears.